considerable amount of movement. Now if I head into my project settings and under input, this is the right way to do it. The brute force way would have been like doing this on tick, and I'll just show you. This really shouldn't be your option, but I'll just show you just in case. So for example, we could just have a boolean here and we could just set this to true, for example, and when you release it we could set this to false. Now this is wrong, so don't really worry about the logic. This is just gonna work, but you shouldn't really do this. So we could do if new variable is true, we want to move, otherwise we don't want to do anything. So if I go ahead and press play, I can press W and move, but as soon as I release it, I'm going to stop. This is the brute force way to do it, but Unreal has a much more elegant system to do it. So we can go ahead and delete all of this. Head into our project settings once again. And under input, you would see action and axis mappings. Now we want an axis mapping because we do want to be able to control the scale. And since add movement input is actually a function which depends on the scale value. So remember what I told you about the joystick. So we can create an axis mapping. So for things such as jump, where there is no scale value, so it's either jumping or not jumping. So wherever you have a toggle, you'd have an action mapping. Wherever you have some value which goes linearly, you'd have an axis mapping. So we can call this one move forward and make that Pascal case, and we could have W on the keyboard for that. And again, for move backward, we could reuse this actually. So S is going to be move backward, and for the scale value, you can make this -1. Now, if I right click over here and if I type in move forward, you would notice that we have an axis mapping. So if I grab this into this input event, or rather if I bring this into this axis move forward event, and for the scale value, if I put this under axis value, now this will work exactly as I would want it to. So if I go ahead and press W, it's going to work, and even S is going to work now for us. So this is basically how you do axis mappings. Similarly, you could do it for move right. So we could have move right, or we could call it move sideways. And we'd have our A and D keys. So we have our A key and we have our D key. So D is going to be this one and it's going to be -1. So let's actually just test it out. So it's not really doing anything because we didn't set up the logic obviously. So move sideways, whoops, axis move sideways. So once you have the event set up, you can go ahead and add the movement input, and again you can get the right vector of the actor. So basically the right direction of the actor is going to be your right vector. So your forward vector is always in this arrow's direction and your right vector is going to be a vector in this direction basically. So right vector, and if I go ahead and press play, so it's always 1, so that's the reason it's happening. So if I plug that into the axis value, I am moving reverse actually right now. So that's just a simple mistake I did here. So I can type in -1 for this and I can type in +1 for this. Now everything should work as expected. So if any of your directions are reversed, just multiply the axis value by -1. Now as you can see, we are able to move forward, left, right, and all of that good stuff. Now that is about it for the keyboard input. However, if you were to notice, I really can't rotate the character. So let's actually set that up first. So first things first, head back into your BP character, and the functions which we require to set up keyboard input, mouse input for our character is going to be your controller pitch input and your controller yaw input. So controller pitch input and controller yaw input. So these are the functions that we need. Now again, since our mouse needs to be captured as much as possible because it has to detect every tiny movement, so we again need to create an axis mapping. So go ahead into inputs and create 2 new axis mappings and call one look around and the next one, call it look up. And for this, look around is going to be the x-axis of the mouse, so type in mouse x. And for this one, type in mouse y. So that should be good. And over here, if I go back and if I type in axis look around, and we can go ahead and add yaw input over here. And over here, axis look up. Oops, I misspelled that. So head back into input, so look up. Now if I go ahead and compile this and press play, you would see that I am able to look around. However, I really am not able to, look up and down. That's mostly because your character isn't really meant to rotate along with it. So that's the reason it's happening. So if I head into my camera and enable use pawn control rotation, and if I press play, you see I am able to rotate my camera. However, there's one small problem here. We are again doing it reverse. So again, in that case, as I told you guys before, just change the scale value to -1. Now if I go ahead and press play, you would be able to see that our camera is working as expected. Now there is one slight issue though, that is our view is kinda off, which you can fix. But when we actually look up, our character doesn't seem to be looking up. But the reason that's not happening is because you can't just rotate the whole character. Now if I were to actually go to this main tab over here under BP character, and if I search for control rotation, so if I type in control rotation and if I enable it to use pitch, you would actually see that I am in fact able to do that, but there is a small problem. Now if I hit F8 to unpossess my character, you see he just rotates like that. However, we want only his spine to rotate, and that is something which we have to set up using an animation blueprint, which we will do later. So for now, we'll just disable this. And even for the yaw part, you could disable this, and you could technically do something like this and maybe set up some other logic in order to actually rotate your character, but for our purposes, we'll only do it for the pitch. Another tiny thing that I would love to cover here is how do you actually set up different sensitivities? Because obviously right now, the current sensitivity may be a little too much for some maybe it's a little too less. So the way you do that is you just multiply this axis value by your sensitivity value. That's basically how you do it. So multiply this and multiply this as well. Press Ctrl D to duplicate that. Now we could just promote this to a variable. However, remember that this BP character refers to only the character which we are playing. So let's say we are playing a death match or something where your character dies and you respawn with a new character. You would have to pass in the variable every time. So instead of doing this, we are going to set this up in a class which will be common even when your character is destroyed. So the class which we'll use, and as you would expect, is called player controller. So go ahead and create BP player controller. So make sure everything is in Pascal case. Now if you open this up, now over here we can go ahead and create a variable and call this one sensitivity. And now this is going to be of type float obviously. And let's make this one private. And let's create a method to get the sensitivity. Now this player controller is going to be persistent even after your character dies. So that's the reason we are using it. And since we need the immediate value, this will be pure. And for the return value, we are just going to return the sensitivity. Now obviously, the reason we are doing it this way is you don't want an external entity to actually modify sensitivity, that would be crazy. And one more thing, make sure you set this value to anything other than 0, because if it's 0, your mouse obviously will not move. So maybe something like 0.5. So once that's done, I should be able to set my player controller first of all. Over here in your game mode override, for your BP game mode, go ahead and change your player controller to the one you created. Save that and open up your BP character. And now on begin play, what we can do is we can actually get our player controller. So we can type in get player controller and we can cast this to our, as you would guess, BP player controller. So we are getting our player controller and we are checking if it is a BP player controller. Obviously we set it over there in the game mode, so it will be. There's no way it's going to head into cast failed. So we can just right click and make this a pure cast. So this just helps us save some space in the graph. This will be a success for sure. And we can go ahead and type in promote to variable and we'll call this one PC ref for player controller ref. Now go ahead and compile that. Again, you can go ahead and make this one private, but honestly it doesn't matter in this case. So on begin play, we have gone ahead and stored our player controller. And from our player controller object, we can go ahead and get the sensitivity. Go ahead and get the sensitivity. Go ahead and do the same thing over here. Compile that. And if I go ahead and press play, you would see our sensitivity works. And not only that, actually, if I go ahead and change the value, so let's say I make this 0.01 or rather 0.05 for example. 0.01 would have been too less. Now as you can see, I can make very precise movements. So now this sensitivity option definitely works. So this is how you would actually go about setting up sensitivity. Obviously if you really didn't care, you could just have a variable here and stuff like that. Doesn't really matter honestly. And there's another thing which you could do is first on begin play itself, you could go ahead and pass your sensitivity over here and you could promote this to a variable over here. And instead of calling the function every time, and make this one private once again, instead of calling the function every time, you can go ahead and use the sensitivity variable. So that's a little more better in terms of performance. This is something which you could do as well. Now remember, we are only able to do this because the player controller is always created before your character spawns. Let's say your player controller is not yet created by the engine, you can't actually do this. So let's say I go to my player controller and I'm not sure if I can do it on begin play. Maybe it would work on begin play, but technically if I type in get player character and if I type in cast to my BP character and if I go ahead and print a string, copy that over and I'll just type failed for this, and doesn't matter to be honest, and I'll type in success. Now if I go ahead and press play, you see we get success. However, this happens only because our player controller is probably created, or rather the begin play is actually called after the character is created as well. However, now I'll just show you guys another class. Now we'll discuss more in depth about this, but if I just type in game instance, I can go ahead and create a game instance class, and this is actually referring to your whole game application. So if I type in event init, this is when your game starts. It's not like the begin play where you're actually, talking about when this entity is created. The event init is actually called when the game starts. So that's one difference. So over here, if I go ahead and put this logic over here, and if I go ahead and go to my project settings and change the game instance to new blueprint, we'll delete that soon. And if I go ahead and press play, you see it says failed because our character is not yet created. So that's one thing to note. The begin play logic only worked because our character was already created. Now let's say we added a 2-second delay. Now this is gonna work. So now if I do this, it's gonna work because our character is now successfully created. So that's basically one thing that you guys need to understand. Just make sure all your entities are valid before you actually set them, and we can go ahead and revert our game instance. So again, we'll talk about all of this more in depth. This is not something which you would really worry about at a beginner level. Now save everything, and that should be good to go. To go a little more in depth on the part where you'd actually check if this object is created. So in our case, I mean, everything just worked out smoothly, but what if it didn't? What if this wasn't valid yet? Because as I told you guys, the default value is none. What if this wasn't valid? Well, there is a fix for that as well. There is actually a function called isValid. So if I go ahead and type in isValid, there's actually a macro which is created for us. So what we can do is we can go ahead and actually do this. So if we can convert this to a normal impure cast. So on begin play, we can go ahead and do this. We can check if it is valid, and if it is not valid, we would not want to do anything. But I mean, if it is valid, we want to set the reference obviously. But if it is not valid, we want to again check after a while. And if it is valid, obviously after setting the reference, you would want to go ahead and set the sensitivity and do the regular stuff. Now what if it's not valid? Now how do we actually check once again? So for this, you would use a technique known as polling. So polling is where you repeatedly call a certain function until a certain condition is met and you actually get your desired result. So the way you can do this is by using a timer, and that takes us to the next important concept. Now if I right click and type in set timer, you'd see you'd get a few nodes over here. However, the only one which you'll use is set timer by function name. Set timer by event is kind of pointless in my opinion, because even if you do use this, you can actually refer to an event by the function name itself. So most of the times you would be using set timer by function name. So use set timer by function name. Now it returns us a timer handle which allows us to control this timer. And what this basically means is it is going to call the function with a given name. So we can right click on this and type in collapse to function, and let's call this one, for example, get references, or let's call this one initialize. And we don't really need this in the event graph. And over here we can copy over this name. So what we are basically saying is after certain time, call this function once again. So we can have a very small time such as 0.01 seconds and make this one looping, because if you just set this to 0.01 without the looping, it's just going to execute it once. And we can go ahead and store the handle of the timer. So we can call this one initialization timer. And once we have that, this timer is now set, and we could just comment it out and call this one polling for references. Again, you could name it a little more descriptively. You could give it a color as well. That's one cool feature in Unreal. Honestly, you would never use it, but yeah, I just showed it. And under initialize, we need to stop the timer once we actually finish everything. So once we finish setting the sensitivity, there's no reason for this function to run again. So we can go ahead and get our timer handle first of all. And if you just type in clear, you'd get an option called clear and invalidate timer by handle. Go ahead and call that. This is how you stop the timer. Copy this, and if it is not valid, we don't really want to do anything. And if the cast failed, again, we don't really want to do anything. So again, yeah, this cast is bound to fail actually. This check is kind of useless in this case. So we can just go ahead and do this, because if we don't have a play controller, this cast will obviously fail. But anyways, I'll just keep it like this. And now if I go ahead and run this, what will actually happen is every 0.01 seconds, it is going to repeatedly call the function until we have cleared it. So once we get all the references, we go ahead and clear the function. clear the timer. There are some key differences though between doing this and using a delay. Obviously you could have done this as well. So you could have done delay, and let's say we gave 0.01 once again, and over here we can go ahead and call initialize, and we can go ahead and loop this. Obviously we can call this first. So initialize, then after 0.01 seconds we could do this, and maybe we could check if we have all the references. We could maybe return a boolean over here or something and do something like that. The difference between a delay and a timer is that a timer is going to be very precise. It is going to be precise usually up to micro or even nanoseconds if you have a precise timer. This one I believe is precise up to a couple hundred microseconds. So as far as my testing is concerned, you could use chrono in C++ and actually test it. So this is going to be accurate. However, a delay is going to be very inaccurate. So that's one thing to note. If you want something to time accurately, you would use a timer. Or in our case, we needed the looping functionality, so that's the reason we used the timer. Since we have built a fundamental idea on how inputs work, now we can go ahead and check the other type of input, that is input action mapping. Now before that, let's actually just clean this up a little bit. So just comment it out and type in movement, and maybe you could type in movement and camera maybe. So movement and camera. So now we can just group these. Now head back into your project settings, and under input again, if you look at action mappings, you can go ahead and add one, and we can call this one interact, and we could set that to the F key. Now the advantage of using it through the project settings like this rather than brute forcing, so you could do F over here as well. So if I just type in F and give a space and type in keyboard, I can actually do this, but this is not the proper way to do it, because these action mappings can be actually changed through your in-game settings menus. So you can actually create a menu inside the game and allow the user to change, or allow the player to change these key bindings. So we'll call this one interact now. So action event interact, and this gives us a pretty basic pressed and released option. So when we actually press it, so we want to be able to pick up an actor. Now how are we going to actually set this up? So first things first, remember we had our actor begin overlap. Instead of doing it here, it's always advisable we do it from the character. So do your actor begin overlap here, actor begin overlap. Once you call the actor begin overlap, over here for the other actor, instead of casting to a character, since we are the character ourselves here, because we are inside the character class right now, we can cast to the pickup instead. Now that we have casted to BP pickup, we are checking if this is actually a pickup. Now there is a better way to do it using interfaces, but that is a much higher level concept than casting, but I will definitely get to that a little later in this course. So we'll probably change this to use an interface. Even that is casting at the very fundamental level, but that's a more elegant solution to do things. Now if this is actually a pickup, we can go ahead and actually store it. So promote to variable, and let's just say let's just call this one nearby pickup, and what we can do is on our actor end overlap, so end overlap, over here we can go ahead and again cast it, first things first, and if it is, we can check if it is equal to the nearby pickup, and if it is equal to the nearby pickup and we have left its bounds, we can go ahead and remove it and invalidate the reference. So we can alt drag it and we can set it to be equal to none. That is going to invalidate a reference. So that's about it. Now once we have our reference, what we can do is we can head in our interact function, check if this is valid. One more way you can do it is by right clicking and converting this to a validated get. So if our pickup is valid, which means we are near a pickup, so what we can do is we can actually call a function. For now, let's just print out a string, let's say. So, or rather we can just destroy it. So type in destroy and you will get destroy actor. If I go ahead and press play, and if I go close to it and if I hit interact, you see I destroy the pickup. And if I do that once again, that is not gonna work. The reason is, once our pickup is destroyed, it's no longer valid. So what we have to do basically is check once again if we have any pickups nearby. So that's actually really easy to do. So once we destroy it, we know that our nearby pickup isn't actually valid. So we can go ahead and set our nearby pickup to the nearest one. Now how do you check that? Again, using a function. So we want to see if we are overlapping. So type in overlapping. And you already see you actually get options for get overlapping actors, which is exactly what we need. And for the class filter, it's obviously going to be BP pickup. And over here, we get an array of actor references. Instead of getting all of them, we can just get the first one. This is an array, so obviously we have to get the first index of the array. So once we get that, we can go ahead and cast this to BP pickup once again. And it is going to be successful all the time, so we can just make this a pure cast because we are actually using the class filter here. And then we can go ahead and set the nearby pickup. So now our logic should work for both the pickups. So if I hit F, one of the pickups got destroyed. So I shouldn't have moved back actually. So if I press F, one got destroyed. If I press F again, the other one got destroyed as well. And there are no errors. So this is basically how you do something like a pickup. Now obviously, before you destroy it, let's say you had some properties. Let's say for example, let's say this was a health portion or something which gave your player a couple of health points. So we can add in, I don't know, let's say health points. Obviously you'll have a better inheritance hierarchy and we will get into that. So health points, make this a float. Let's say we have 10. So what we can do is, for now we can just go ahead and print it. So we can grab this health points and we can just print it out. So move all of this logic a bit over there to make space. We can just print that before destroying it. Make sure you call print before destroy, otherwise you're going to get a log error. Now if I go nearby, if I press F, we are going to get 10 printed every time. So that's basically how you do it. However, let's say you wanted to change some of these properties depending on which pickup it is. Now, apart from having these as a variable, you can go ahead and check these two options called instance editable and expose on spawn. What these will do is allow us to edit these properties when we actually spawn it. So let's say we spawn a pickup, for example. So over here, let's say I do spawn actor. Let's say we spawn a pickup. You see, we actually get an option to change our health points. So we could do something like 90, for example. And for the spawn transform, we can just get a random location, let's say. Let me just add in something for us to recognize. So something which you would use for such a case is called a target point. So you can use a target point. So this will represent a point in space. You can copy this over and we can go ahead and paste it in. Or okay, maybe we can't do that here. You can do it in the details panel. So 1150 and negative whatever this value is and 650. So 650. And we have health points set to 90 over there. Now as you would see, we actually spawned another pickup. Now if I go ahead and pick these up, you get 10. But when I go near this, I get 90. However, it need not be restricted to spawning it through the blueprint. You can actually edit expose on spawn variables right here as well. So even when you're placing them in the level, you could have this to be 20, for example. So if I go nearby, you'd see 10, 20, and this one is obviously going to be 90. So stuff like that, which you can do using expose on spawn. You can expose any variable on spawn and they will be passed right into the actor, and the value which you pass in would be set to that variable. And now we can go ahead and remove this logic. That was just for showcasing purposes. And we can go ahead and collapse this to a function and call this one, call this one pickup. And along with this, maybe we could also have something like door open or something. Let's say this is not valid. We could go ahead and perform door open or something like that. We could go to the return node and we could have a sequence node here. So first we would check for a pickup, and we could also do something like a door open or maybe anything else probably. Maybe if you had some sort of an interaction system with a player or something, so you could interact with the other player. Stuff like that, which you can do using these input bindings and using the overlap events. To showcase that, let's actually do one more of the interaction events. Now I will show you guys how to do it the better way with interfaces later, but this is the brute force way. And if you have maybe 1, 2 or maybe 3 or not more than 4 interactions, you could use this method itself, the one which we did with casting. So this is totally okay for small things. Now let's actually do it. So right click, create a new actor, and let's call this one interaction actor. Maybe we could just nudge it or something. So let's say we have another static mesh, make that the root component, and we need some sort of bounds, so sphere collision maybe. And for the mesh, let's just take a cone for example. And also I've gone ahead and deleted the code which we had inside BP pickup since we are not using it. And over here, go ahead and simulate physics. Make sure you don't forget that. And we can go ahead and, okay, maybe we can have a smaller one for example. So I'm not really sure. I'm just looking for any mesh that's available to us because we haven't imported ours. Okay, this is way too big. Okay, this sphere seems like a reasonable size. We can go ahead and increase our bounds. That's about it. And once again, over here we can head into our BP character, and what we can do is we can copy over the same logic. So instead of nearby pickup, we are going to have something else. So if this cast fails, so if whatever we are nearby is not a pickup, we can check if this is actually an interaction actor. So we can do cast to interaction actor, and again, other actor is what we are checking. If it is the interaction actor, we can go ahead and promote this to a variable and call this one interaction actor. Again, I prefer going with Pascal case. Alright, now when we actually go away from it, we can again do the same cast. So we can copy this over, we can paste it, and for this actor, if it is equal to the interaction actor which we were nearby, so copy this over, grab in the interaction actor. If it was in fact the interaction actor, then we can go ahead and invalidate it and set that to be equal to none. So that should be about it. Now over here in the interaction logic, we can go ahead and check if this is valid. Right click, convert to validated get. So if we are near an interaction actor, what we can do is we can, instead of destroying, let's actually add impulse. So add impulse. So add impulse. So we want to add impulse to the root component here, which is simulating physics. Basically, these are the physics functions. You have impulse, force, torque, and all sorts of stuff. Obviously, you could spend some time and study those, but we'll not get into that. So we have a sphere here. So static mesh is the root component. So we need to get the static mesh. If I go ahead and scroll all the way down, I should see get static mesh. Now this variable refers to the component. Even components are objects, so you can just get them as variables. And for the impulse, what we can do is we can go ahead and get the forward direction of a character, get forward vector. Now you could change it according to your, this is logic based, so it's nothing much really. And we can multiply this by a certain value. So we can make this one a float and change this to a float. Make this, let's say something like 10,000, something big maybe. Get actor forward vector, multiply that by 10,000, and that should be good to go. Now we can collapse this to a function, and we can call this one nudge ball or something, because the sphere looks like a ball, so nudge ball maybe. And if I go ahead and press play, okay, we have a compilation error, so we can check what's that. So it says, let's read the error first of all. Okay, it was just, it just compiled it in the wrong order. It compiled character before this, so it didn't know what static mesh was. Now we should be able to go ahead and play this. And first of all, we don't have an interaction actor. Let's actually create one. Go ahead and press play. Now if I go ahead and bump into this, oops, I shouldn't have bumped into that. If I press F on my keyboard when I'm overlapping it, the bounce is a little too small. Let me just increase that. So increase the radius, don't scale it up. And one more thing, if you want to see the bounce just for testing purposes, you can set this flag called hidden in game to false. So now it is going to be visible in the game as well. So if I look around, yeah, there we have it. So we can enter our bounds. And now if I press F on the keyboard, you see we actually nudge it. So the force is way too small. So I can go ahead and make this something like 50,000, let's say. So if I go ahead and press F over here, you see we are actually nudging it. So this is the way you would set up interaction using casting. Obviously you can use interfaces to simplify things a little bit. But yeah, this is the basic idea. Alright, so in order to understand whatever I just told now, in case it went above your head, please do tinker around and try some of the functions yourself using the context sensitive and the search bar basically. So when you right click and let's say you drag something off of this, you can go ahead and type any random function. So for example, if I just press A, you get a bunch of functions. Maybe you could have a look at all of these. Maybe have a look at documentation and maybe try out some of your own logic and try out something else. Maybe add in another actor to do something else with, maybe add in a door and make it open or something. So you guys should be able to try it out yourself. And once you are actually done with that, now we can go ahead and talk about the next part. Now, until now, we talked about the basics, and I'm pretty sure you can write some basic game logic with whatever we have done already. But there are a couple of functions which the engine provides us, which is going to make our job a lot easier. The first one, and one of the most commonly used ones which I would like to talk about, is raycasting. Now, if you guys are familiar with other engines, you guys would know what a raycast is. But in Unreal Engine, you call it a line trace. So if I right click and call line trace, so you see you get a bunch of options. The one you'll use most of the time is line trace by channel. Multi is basically used when you have penetration and stuff, when you are detecting multiple hits in the same line. I'll tell you guys what's line trace first. So line trace is basically a function which lets us draw a line from a given starting point to a given ending point, and in between these 2 points, if you are actually hitting anything, you are going to get it as a hit result. So I can get access to the hit location. And in case you want to see the line itself, you can change this draw debug type enum and make this for duration. And if you guys wondered, this is an enumeration. That's the reason we are getting these options. So none, for one frame, for duration, and persistent are the enumerators. So if we select for duration, we are going to get the line for some time. Persistent means the line is going to be shown to us forever until you close the game, of course. So let's actually do something with this. So let's actually set up an input event. Let's say when we click our left mouse button, so we can type in left mouse. Now I'm just setting this up brute force because I don't really know what exactly we are going to set up. Once we actually get to the examples, we'll do that. Now for the start location, you can choose the camera's location of the player because this is where you would be seeing stuff. So you can select the camera's location, for example. So if I go ahead and get the start location, the way you do that is there are a couple of ways. You could do this and you could do get location. So you can get world location and you could use this as a starting point. And the way you would go forward towards the center of your screen is going to be first of all by getting the forward vector. So you can get the forward vector of this camera and multiply this by a certain value, again by a float. We'll do that. Add that to the starting location. So starting location plus forward vector into a certain number that is going to be your end, and we can go ahead and change this to a float, and we can do, let's say, 50,000. I mean, the number is arbitrary. Obviously Unreal uses centimeters, remember that. So anything that you type in will be in centimeters. So 50,000 centimeters is going to be divided by 100, so it's going to be like 500 meters. Now if I go ahead and press play, if I press my left mouse button, you see you get a line drawn over there. So if I press F8, you see I can actually see the line which was drawn. So the red thing which you see, that is the line which was drawn. And as you can see, where it hit the surface, it actually registered a hit. And in order to show that, there is one more thing which you can do actually. Oh, and about the other options, trace channel is something we'll talk about later. But basically you can do stuff like ignoring several types of objects. So let's say you had a shooter game and let's say you wanted to like ignore teammates, you could use it for that. But you'd use tags for that as well. But there are several other use cases. Camera is another thing. Depending on what type of objects you want the hit to detect, you would do that. And actually if you were to notice, if I select my mesh, and if I scroll down to the collision part, so I'll just type in collision instead of searching for it like this. So collision, you were to notice it says character mesh for the preset, and over here if you see there is actually visibility and camera. So what you can do is you can actually make it block certain things. So now let's say I wanted this line trace, which is using visibility right now, to block it. I would have to change this to custom and make this one block visibility. So then I would be able to make this line block it. Stuff like that which you could do. Now obviously I'll change it back to character mesh. We didn't do anything, but still. So over here, change it back to character mesh. And let's say you wanted to ignore the camera channel, you could do that as well. Now let's say you wanted to just mark the place where you actually hit. So now we have access to the hit location. So there is a function called draw debug sphere. You can actually draw many other shapes, but sphere is the one which you'll use most often. And the center is obviously the place where you hit it. So out hit location and radius 100. Maybe we can have 10 seconds for the duration, and thickness, let's just say 2 units. Line color, let's set that to maybe something like a greenish yellow or something. Now if I go ahead and press play, if I left click, you see it's drawing a sphere where it actually hit it. And you could change some of the properties. Let's say you wanted a more detailed sphere. I don't know why you would want that though. And maybe reduce the radius of the sphere. You could do that as well. So as you can see, we are registering a hit over there. So that's what it's basically showing us. So this is how you do a line trace. Basically you draw a line from one end to the other and you can detect hits. Obviously for shooting a weapon and stuff like that you use it. Now there is another way you can actually determine the start and end location. Now whatever logic you have here is fine if you only have one camera. But what if you had a first person view and a third person view, for example? Let's say you had two cameras. You cannot check which camera you're using and stuff. That would make the logic complicated. So the way you do it is you'd use a function called getPlayerCameraManager. Now this is going to get the current camera which you're using, and it's going to be an actor. So we can just type in get actor location, and this is going to be your camera's location. So let's say you switch between cameras. This is going to work universally regardless of which camera you're using. However, since in this logic we are using this camera's reference, let's say we had another camera, this logic is not going to work. It is going to work with respect to this camera. So instead of this, I can go ahead and replace it, and we can get the actor forward vector again, get actor forward vector, and we can replace this by this, and we can go ahead and delete it, and the rest of the logic remains the same obviously. And now if I were to press play, you'd see that the logic does not work. Okay, we didn't plug it in. So the actor location is going to be the start, of course, not 0. Press play and the logic works exactly the same. One more thing you'll notice is that the line trace is going exactly to the center of our screen, if you were to notice. That's one more thing. The reason it's happening like that is because we are going from the center of our viewpoint and going exactly forward to the view. So that's the reason it's actually going right at the center of the screen. And if you had a crosshair in game, it would land right at the center. So this was raycasting. There are many other options as well, such as hit actor. So you can cast it. So let's say we cast it to pickup, for example. So we can check if we actually hit a pickup. So if we actually did hit a pickup, what we can do, in fact, is we can go ahead and run some logic. Let's say we destroy it. So I'm just showing you guys one more example to make things clear. So if I press play, so that's not a pickup, so nothing happened. But if I hit a pickup, as you can see, we are destroying it. So something like a gun. All this is fine, but we do not have any sort of a user interface. Now, apart from the lighting needs to be rebuilt thing, you can actually delete that by typing in disable all screen messages. So, oops, I didn't type that. So, disable all screen messages. So, you can go ahead and type that and it's going to remove that. So, there's nothing much really. We don't even have a simple health bar. So, we can go ahead and add a couple of components on screen. So in order to create widgets on the screen, if you want user interfaces, the way you do that is using widget blueprints. So let's get to that. Inside your content folder, I want you guys to create a new folder and we can call this one UI. And inside this, we can call this one, for example, HUD to denote heads up display. Now open it up and inside this folder, right click and create a widget blueprint by heading into user interface. Now you could do it through the blueprint class menu as well. Type in widget blueprint. You should find a widget blueprint somewhere over here. So user widget is the one actually. So go ahead and select that. And we can call this one HUD BP underscore HUD. Generally, I also like to add underscore WB to represent widget blueprint. But if we are going to have separate folders for each one, it's not really required. Open it up and you will get a blank canvas and you'll have two tabs over here on the top. You have a designer and a graph as well. So what we'll be using most of the time is the designer, and to add the logic for it, we are going to use the graph. If you guys have used the Qt framework in C++, the functions and stuff work pretty similarly over here, but since this is going to be in Blueprint, it's going to be much easier to comprehend. Now, the most basic type of widget that you can add is a canvas panel. So add in a canvas panel. Before, this actually used to come by default without you having to actually add it. Now, you won't worry about most of the settings actually. The only thing that you'll worry about is custom or filled screen actually. These are the only two which you'll most probably use. Custom is basically used if you have stuff like drop down and you're making like a child widget for something. And I will show you guys examples for that when we go to the higher level part. So for now we'll use fill screen. So this is going to take up the entire screen. Now in order to actually create this, now there is nothing, but we can just create it nonetheless. Generally it's not advisable to create it in the character. Widgets usually would be created in something a little more persistent, such as a player controller. So we have one set up already. So we make sure you set that in the game mode, open it up, and we could do it on begin play. Add in a custom event, and this is where you actually use custom events. So you could use a function, no harm with that, but let's use custom events. This is what you would use them for. So we are going to be calling this one, for example, create HUD, and we can call that, so create HUD. Over here we can go ahead and type in create widget. We'll get to select it, so BP HUD is what we want to create, and we can promote this to a variable and call this one HUD, or you could call it HUDref if you really want to be that specific. Now we have a reference to the HUD. However, we still haven't actually created it. We have just internally stored it, but if you want to show it on the screen, type in add to viewport. So now this should be added to your screen. However, there is another thing which you could do actually. There is another option called add to player screen. However, this is not really used that much. So this is usually used for split screen and stuff like that. We'll not get into this. So you'll use add to viewport most of the times. Alright, so now under your HUD, for the health bar, obviously we need a progress bar. So type in progress bar and Unreal has everything built in for us. So let's add it at the bottom left hand side of the screen. That's the reason I chose the canvas panel, so that we can easily just drag stuff in. With other types of widget, it's usually like a layout which you create, so it's going to be harder for you to just move things around. Alright, so let's add the progress bar, and on the right hand side under the details panel we can rename it. We can call this one health bar, and we can set all sorts of parameters. Maybe we can make this one 350 by 45. And over here you'll see another tab called anchors. Now anchor is basically telling you the position with respect to it. Basically, for example, let's say set it to bottom left. In this case, bottom left is ideal. So this is going to be your 0, 0, and with respect to that, your y and your other values are going to be set. So when I say the anchor is at the bottom left and my position is 88, what I mean is I have placed this progress bar 88 units to the right of this anchor, and y is basically your vertical direction. So minus 120 is 120 units upwards basically, and size x and size y will remain the same. Alignment is basically telling you what to take as the reference point. So if I make this 0.5, you see it's going to center off. So it's the distance between this and the center now. Same with the y. So if I type in 0.5, it will move a little bit down or up actually, because it was over here. So now the point shifted over there, so it moved a bit up. And if you want to center something exactly at the center of the screen, so for example a crosshair, so you would set the anchor to be this, the center one. And over here you'll change the alignment to 0.5 and set the position to 0 and 0. Now this is going to be perfectly centered regardless of your resolution. Now another reason to actually use this, so let me just actually move this back, so 0, 0. Another reason to use anchors is for different resolutions. Let's say you had an 800 by 600 screen. Let's say somebody is playing with that and you had a progress bar over here. Let's say you left it at the default anchor. Let's say you didn't actually modify the anchors. This widget is actually going to go outside the player screen. However, if you change the anchor to the bottom right, now this widget is minus 461 and minus 137 relative to the bottom right corner. So then it will always be inside the screen. So that's another reason to use anchor. So I'll go ahead and undo all of that. So that should be good. Now if I go ahead and create this, so in our player controller, on begin play we are actually creating it. Now if I go ahead and press play, you see we see our progress bar. And since we have our anchor over here, you see it always stays at the same relative position on the screen. The next thing that you obviously want to do is actually bring in the values of health from the character to the actual widget. So it's actually pretty simple to do that. So let's go step by step. There are quite a few ways in which you can do it. So if we would have created the widget on the character, it would have been simple to just pass in the health value to the widget. However, since we have done it in the player controller, there is an extra step, but nothing to be worried about. So now let's create an event in the player controller so that we can actually interact with the widget. So we can call this one update health, for example. So type in custom event and call this one update health. And for the new value, we can go ahead and add in an input, and it's going to be of type float obviously, and we'll call this one new health. Now over here in the progress bar, we can go ahead and create another event, or we could even directly adjust it here. So we could get the HUD, and over here we could type in, first of all, let's check if our progress bar is a variable. Make sure it's set to is variable, otherwise you won't be able to access it. So if once that is variable, get the health bar. And again, this is where your blueprint menu is going to help you a lot. Now you want to set the percentage. So type in set %. You will go ahead and get this node. Now in case you guys don't know, this % is going to be a value between 0 and 1, and our health is a value between 0 and 100. So let's just divide this by 100. So do that, or you could make your health variable store 0 to 1, that works too. Alright, so you can do that, or you could have a custom event inside your BP HUD, that works too. So let's head back into a character now. And what we can do is we can actually do something. So let's say when we actually pick something up, let's say we reduce our health, for example. So we can head into our interaction. So when we pick it up, let's say we reduce our health by 10 maybe. Now if it is valid, we destroy it and we invalidate the nearby pickup. And let's reduce our health by 10. So create a health variable first of all. Now health is a variable which is dependent on which character you're in. So that's why we are creating it in the character. Make this private over here. Make this variable private. And we can go ahead and set the health to be equal to, we can go ahead and set the health to be equal to health minus 10. And we don't want it to actually go below 0. So we can go ahead and clamp the value. So we can call this one clamp. So clamp float. Minimum is 0, maximum is 100 obviously. So you can go ahead and set it. Now if our health is 0, so if our health is less than or equal to 0, if you don't clamp it, you can check for less than or equal to. So let's do that actually. So if our health is less than or equal to 0, less than or equal to 0, we can go ahead and just kill our player. So instead of killing it, let's just exit the game instead. So we can we can execute a console command. So type in execute console command, and this one we'll simply type in exit. It's going to exit the game. Even quit works. Now this is something which you might need multiple times. So what we can do instead of this is we can actually make a set health function, because we want to exit the game even if our health is reduced for some other reason. So here in this case we picked it up so our health reduced, but we want to be able to reuse this. So right click, collapse this to a function and call this one set health. Now let's say you don't want this to be able to called on the other blueprints. So let's say you want to only be able to call it in this BP character. You can make it a macro instead. And obviously we need the health value. So grab in health and head back into your event graph, pick up. Over here we can go ahead and pass in the health. So this is going to handle everything for us. And let's actually make this a larger value. Let's say 40. So on our third pickup, in theory we should exit our game. And if it is not less than or equal to 0, we can go ahead and update the progress bar first things first. And remember we had our player controller reference. Now we can go ahead and use that. So regardless of what we do, we want to update the health bar. I mean, we'll exit over here, so we don't need to update it. So we can type in update health. And new health is going to be our health variable. Now, some people might show you how to do this using a binding. So you can actually go into your progress bar and you can type in bind and create a binding. However, this is very inefficient and it is going to run on tick. So actually don't really bother using that. Do it the way I am showing you guys. This is the proper way to do it. However, there is a small chance that it might miss. It might not update. But that's nothing to worry about. It's going to be like 1 in a million maybe. So it honestly doesn't matter. So once that's said, we should be good to go. And make sure by default your health is set to 100. And once just update the progress bar once you set the player controller reference, because we are not actually setting the health by default. In the HUD you could set it. However, what if a player disconnected from a match and is coming back? So you don't want it to be 100 because you'll be creating the widget once again, right? So set it once you get the player controller. So in our initialize function, once we get the player controller reference, we can go ahead and set that. And we'll clear the timer at the last. Order doesn't matter here since this function is already being executed. The order honestly doesn't matter, but we can do it like this. Now if I go ahead and press play, you'd see our health is set to 100. And if I go closer, okay, let me just speed that up a bit. So if I interact with this, nothing happens. But if I go ahead and interact with this, our health reduces. My health reduced. And now we exit the game the third time we do that. So this is basically how you work with widgets. So if you want to update it, you would just use one of the functions which are there in one of these widgets. And what if you wanted text? Obviously, you would just search accordingly. Type in text and you should be able to find text. So let's actually type in the actual health value. So over here, what we can do is we can just give 100 by default, or we could leave it a text block and set it normally. So over here, get back into your player controller and in your update health function, we can go ahead and grab our text. I don't know if it's set variable. So it is not set to be variable. So we can type this one health text. Now you should be able to access health text from the player controller once you set that to is variable. So grab in our HUD, health text. So get your health text. And over here we can go ahead and set the text to be equal to the health value itself. Now there is a special node which you'll use a lot called format text. So this is very simple actually. Use curly braces and type in health. It will make a pin for you. Whatever you type in curly braces will be a pin. And the first one, let's just put a plus over there, because it's usually health is denoted with a plus before. So your text is basically going to be plus along with a health, appended with your health. So let me just show that actually. So grab in your new health. You can grab in any sort of pin, by the way. Now if I go ahead and press play, you see it says plus 100 because it took plus and the actual health value itself. Now I apologize, I do realize that the screen is a little bit black and white. So now it should be fine. So you have plus and you have your health. Similarly, you could do something like maybe hyphens. So it's just going to append it as is. You can go ahead and mess around with it a little bit. Let's say you wanted another parameter. You could put curly braces once again and type this one maybe something. And over here, you can go ahead and make a literal string or a text. So let's just say hi, for example. So it's going to print plus 100 space hi. If I put a hyphen here, it's going to take it as is. So plus 100 hyphen hi. So stuff like that which you can do using this format text node, and it's really handy in my opinion. So now if I go ahead and press play, we have our health bar. Now we could do a little more of designing. So head back into your HUD and you can actually wrap this around with a border. If you right click and type in wrap with, you can wrap it with a border and actually have a border color and stuff. So I can select this and make sure you set your padding to whatever you want. Padding is basically the spacing you give. So if I change the padding in this case, so if I change this to 10, you'd see that you're giving more space on all directions. I'll just set it to something like 5 maybe. And I'll make this one black. So not content color, that's going to be a progress bar color. Instead go to brush color and change that to something dark maybe. And over here as well, let's just change the fill color to green because that's more appropriate for your health widget. So change that to something a bit more greener. Now if I go ahead and press play, you'd be able to see we get the appropriate color and our health bar updates as normal and our text updates as well. So that's basically it. So that's the basics of widget blueprints. We will talk a lot more in depth about this as we move further. But now you guys should have a pretty basic idea on how to create stuff. Now the palette is something which I want you guys to explore. So checkbox is a checkbox and you won't use most of these. Most often you'll use text, slider, button, image, border, and image is, as it says, it's an image. And one more which you might use if you want something like a username password menu is a text box. So you can grab in a text box and this will allow the user to enter any text inside. Stuff like that. Now I want to cover widgets in a little more detail. So let's actually create another level called main menu and let's actually transition to this level using a widget. So like you'd click the play button in your widget and then you would enter this level. Let's do that now. First we can go ahead and create our map. So head into content, maps, right click, create a new level and we can call this one main menu. Open it up, or rather let's just be a little more descriptive, call this one main menu level. Open it up and this should be blank and that's really none of our concern. Head into UI, create a new folder and we'll call this one main menu. Over here, go to user interface, widget blueprint and go ahead and select user widget. Now we can start making our main menu. So we can call this one BP underscore main menu. Open the widget and we can just have a canvas panel again. Add in a button. We can center it first of all. So make it 0.5 and 0.5 and set the positions to be 0. We can increase the size a little bit. Maybe we could make that something like 350 by 100 maybe 450. Again, size is your personal preference. And we can make the background black. So background color, change that to something darker. Maybe something like a dark gray. we can go in and add in some text, and we can call this one play. Now, you can change the font as well, by the way. Under font, you can actually import your own custom fonts. We'll not get into that, but it's actually pretty simple to do it. We'll try to get into that in the later part of the course, but I'm not really sure if I will. So maybe change that to regular, increase the font size to 35, let's say. This should be good. Now head into your event graph and let's call this one play button. So select the button and then under the details panel rename that. Now if you select the play button variable, you should get a bunch of events including on clicked, on pressed, on released. All of these are as they stand, obviously. Maybe if you have a sound effect or something, you could play it on hovered. Or there's another way actually where you can play a sound effect when you hover your mouse. So over here, if I just type in hover, I should be able to find hovered sound. Let's just play, so maybe let's just play this. I mean, it doesn't make any sense, but anyways. And I think there is a clicked sound or a press sound, I guess it's called. So we can play a press sound. So click on button. And what we can do is on clicked, we can go ahead and open our map. So we can type in open level and we can do by object reference. So over here, let's just select our level, beginner course level, and that should be good. Now if I go ahead and press play, as you see nothing happens because we haven't created the widget yet. Now since this is a widget which is the only thing in this level, you could simply go ahead and create the widget here on begin play. So create widget, BP main menu, add to viewport. We don't really need to store it because we are not actually calling any functions. So if I press play, you can see it, and when we hover over it, you see you get the sound effect. However, one thing you would notice is if you actually have your focus on the window, you can't see your mouse cursor. So the way you do that is, first of all, get your player controller. So type in get player controller. This is a static function. So inside any actor, basically, you can get your player controller reference. And from here, there's actually a variable called set show mouse cursor. So show mouse cursor is the variable. Set that to true. And another thing which you can do actually is change the input mode to UI only, so that it only focuses on this widget. There is another option called game and UI only. We'll use that. Set input mode to game and UI only. Grab in the player controller reference. And that should be good. So we can just reroute it. Double click on the pin to reroute it. And now if I go ahead and press play, you see even when I focus it, I can still see my mouse cursor. Now if I press play, you see we transition to the level. Now we obviously spawned at 0, 0, 0, so that's the reason that happened. Now if you want to fix that, you can go ahead and add in a player start where your default player will spawn. So now if I head back into the main menu, play it. If I head in, we will spawn where our player start was. But one thing you'll notice is we still haven't actually got rid of the mouse focusing part. So your mouse isn't behaving like how it should. So what we can do is on begin play. Now we are in our main menu level. Head into our beginner course level. Generally you do it on your player controller. So BP player controller. And what you can do is you can set input mode game only, and we can get a reference to self, and you can also set show mouse cursor to false. So set show mouse cursor, make that false. Now if I go ahead and press play, okay, I mean that wasn't what I intended. Now head back into your main menu, go ahead and press play. Now you see your mouse is going to behave normally. So that's basically how you deal with it. Now you can do your normal gameplay stuff. So that's how you would actually interact with your actual levels and stuff. You would transition levels and stuff using widget blueprints. So head back into UI, main menu, and if we take a look at our code, it's really simple. And our widget as well,